Point to the center of the universe. Go ahead. Pick a direction. Point your finger toward the cosmic origin point, the place where it all began, the heart of everything that exists. You can't. And it's not because you don't know where to look. It's because there is no center. Not in the way you think. Not in any way that makes intuitive sense. The universe, all of space, all of time, all of matter and energy has no center point. No cosmic downtown. No privileged location where the Big Bang happened. Right now, you might be picturing the Big Bang as an explosion. A brilliant flash of light and energy erupting from a single point, expanding outward like a firework. Galaxies and stars flying away from some central blast site, somewhere out there in the void. That's what almost everyone imagines. It's clean. It's simple. It's completely wrong. Because the Big Bang didn't happen at a location. It happened to all locations. Simultaneously. Everywhere at once. Think about that for a moment. An explosion that occurred everywhere, with no center, no edge, no place you could point to and say, that's where it started. The very question breaks down when you apply it to the universe itself. Where is the center? The answer is everywhere. And nowhere. Both at once. To understand why, to really grasp how the universe works, we need to completely rethink what the Big Bang actually was. Not an explosion in space, but an expansion of space itself. And once you see it, once that perspective shift clicks into place, everything changes. For most of human history, we believed we were at the center of everything. Earth was the moving foundation of the cosmos, with the sun and planets and stars revolving around us. It made sense. When you stand on solid ground and watch the sky wheel overhead, it certainly looks like everything orbits around you. The ancient Greeks developed elaborate models with Earth at the center, surrounded by crystalline spheres carrying the planets and stars. Medieval scholars refined these models, adding epicycles and deference to explain the strange backward motion of planets against the background stars. For nearly 2,000 years, this geocentric view dominated human understanding. Then Copernicus showed us we orbit the sun. A revolutionary idea, but still, we imagined ourselves near the center of something. Surely the sun was special, even if Earth wasn't. Then we learned our sun is just one star among hundreds of billions in a galaxy. The Milky Way became our new frame of reference. Perhaps our galaxy was at the center of the universe. Then we discovered our galaxy is just one among trillions in the observable universe. Galaxy clusters, superclusters, vast cosmic webs of matter separated by enormous voids, and nowhere in this structure could we find a center, no cosmic capital, no privileged location. Each discovery pushed us further from the center. Each revelation was a cosmic demotion. But here's the twist, nobody else is at the center either. There is no center. In 1929, an astronomer named Edwin Hubble made one of the most profound discoveries in scientific history. Working at the Mount Wilson Observatory in California, he pointed his telescope at distant galaxies and measured their light. What he found changed everything. The light from these galaxies was shifted toward the red end of the spectrum, redshift. The same effect you hear when an ambulance passes you on the street, the pitch drops as it moves away. The Doppler effect, but for light instead of sound. And he found something shocking, almost every galaxy in the universe is moving away from us. Not just a few. Not just the nearby ones. All of them. The farther away a galaxy is, the faster it's receding. Galaxies twice as far away are moving away twice as fast. Galaxies 10 times farther away are receding 10 times faster. There was a mathematical relationship. A simple, elegant formula that became known as Hubble's law. The velocity of a galaxy equals its distance multiplied by a constant, the rate of cosmic expansion. At first glance, this looks like evidence that we are at the center. Everything fleeing from us in all directions, like we're cosmically repulsive. But Hubble realized something far stranger was happening. The universe itself was expanding. Space was stretching. And from any galaxy's perspective, From any point in the cosmos, every other galaxy would appear to be moving away. The recession wasn't galaxies moving through space. It was space itself carrying the galaxies along as it expanded. Most people imagine the Big Bang like a bomb going off in an empty room, a point of intense energy that exploded outward, flinging matter into the pre-existing void of space, galaxies as shrapnel, scattered by the blast, the explosion happening at a location, with us billions of light years from the blast site, watching the debris field expand. You can almost picture it: darkness, emptiness, and then bang, a brilliant explosion at some point in the void, matter and energy racing outward, eventually cooling enough for atoms to form. Then stars, then galaxies, all of it expanding away from that original detonation point. Forget that image completely. Erase it from your mind. It's not how the universe works. The Big Bang wasn't an explosion in space. It was and still is an expansion of space. There was no empty room. There was no void for the explosion to happen in. There was no outside or before in any meaningful sense. Space itself came into existence. Time came into existence. And space has been stretching ever since, not expanding into anything, just expanding. This is where language fails us. We don't have good words for this. Expanding implies expanding into something, moving outward into a pre-existing space. But the universe isn't doing that. The fabric of space itself is stretching, creating more space between distant objects. Here's where it gets strange. Think of the universe like the surface of a balloon. Not the inside, not the three-dimensional rubber, just the thin two-dimensional surface. Now imagine drawing dots on that balloon with a marker. Each dot represents a galaxy. Make them random sizes, scattered across the rubber. When you blow air into the balloon, the surface expands, the rubber stretches, and here's the key: every dot moves away from every other dot. If you're an ant standing on one dot, looking around at the other dots, you'd see them all receding from you. The ones farther away would be moving faster, because there's more stretching rubber between you and them. The ant doesn't see the balloon getting bigger in three-dimensional space. The ant only experiences the two-dimensional surface. From the ant's perspective, its entire universe, that surface is expanding, distances are increasing, and there's no center on that surface, no special starting point. Now, here's the question: which dot is the center of the balloon's surface? None of them. There is no center on the surface of a balloon. You can trace your finger on it forever and never find a special point, a central location. Every point on the surface is equivalent. The center of the balloon exists in a direction that doesn't exist on the surface itself. It's in the three-dimensional space the balloon occupies, a dimension the ant can't access or point to. Our universe works the same way, but one dimension up. We live in three-dimensional space, and that space is expanding like the balloon's surface. Just as the balloon has no center on its surface, the universe has no center in three-dimensional space. The center of the Big Bang, if it exists at all, would be in a higher dimension we can't point to, can't access, can't even properly visualize. The analogy breaks down when you try to picture what the universe is expanding into. The answer is nothing, because space itself is all there is. There's no outside the universe in the same way there's no north of the North Pole. The question doesn't make sense in the framework of our reality. But for understanding why there's no center, the balloon gets us most of the way there. Now, you might be thinking, if everything is moving away from us, doesn't that make us special? Doesn't that suggest we're near the center, or that the expansion started here? But here's the thing. Imagine you're a galaxy on the other side of the universe, 10 billion light years from Earth. You look around with your telescopes. What do you see? Every galaxy moving away from you. The farther ones receding faster. The exact same pattern we see from Earth. The exact same Hubble's law. The same relationship between distance and recession velocity. Every observer, everywhere in the universe, sees themselves at the center of cosmic expansion. Because there is no center. Or more accurately, every point is equally valid as a center. Think of it like raisin bread rising in an oven. You mix raisins into the dough and put it into bake. The heat causes the dough to expand, and the raisins representing galaxies spread apart. Pick any raisin. From its perspective, all the other raisins are moving away. The ones twice as far are moving twice as fast, because there's twice as much dough expanding between them. No raisin is special. No raisin occupies a privileged position. The expansion is happening throughout the entire loaf. That's our universe. You're on one raisin, looking out at all the others spreading away into the expanding dough of space itself. But the mind-bending part, the part that really breaks your intuition, is what happens when you trace that expansion backward in time. If space is expanding now, that means it was smaller in the past. Keep rewinding. Galaxies get closer together. Space contracts. The distances between objects shrink. Matter gets denser and hotter as it's compressed into less space. Keep going. Further back. Denser still. Temperature rising. Until you reach a moment, 13.8 billion years ago, when all the space we can observe was compressed into an incredibly small, incredibly hot, incredibly dense state. The Big Bang. That's the universe. Possibly infinite. Expanding uniformly. With no center. Which means something profound. You are at the center of the observable universe. Everyone is at the center. Which means no one is. But the Big Bang wasn't the beginning of space. It was the beginning of the expansion. If the universe is infinite now, it was also infinite a billion years ago, just with everything closer together. Rewind to the Big Bang, and it was still infinite, infinitely dense, infinitely hot, but still infinite in extent. The Big Bang didn't create a finite amount of space that's been expanding into nothingness. It might have created infinite space, already infinite at the moment of the Big Bang, that's been stretching ever since. Infinite space becoming more infinite, in a sense. Every cubic meter of space becoming 2 cubic meters, then 4, then 8. The density dropping as space expands, but the total volume remaining infinite. Try to picture that. An infinite universe that was always infinite, but also had a beginning in time. Every point experiencing the Big Bang simultaneously. No center. No edge. Just infinite space, expanding uniformly in all directions, forever. Even Einstein struggled with this. When he developed general relativity in 1915, his field equations, the mathematical description of how matter and energy curve spacetime, suggested the universe should be either expanding or contracting. The equations didn't allow for a static, eternal universe. But Einstein, like most scientists of his time, believed the universe was static and eternal, and changing on cosmic scales, so he added a term to his equations, the cosmological constant, represented by the Greek letter lambda, to hold the universe still. To prevent the expansion or contraction his equations predicted. Then Hubble discovered expansion in 1929. The universe was doing exactly what Einstein's original equations said it should do. Einstein later called the cosmological constant his biggest blunder. He had the right answer in his mathematics but rejected it because it seemed too strange, too counterintuitive. He let his philosophical preferences override what the math was telling him. Ironically, the cosmological constant has made a comeback in modern cosmology, reinterpreted as dark energy, the mysterious force causing the expansion of the universe to accelerate. But that's another story. And it comes from everywhere, because the Big Bang happened everywhere. There's no direction you can point to and say, the Big Bang is over there. It's in every direction. Behind you. In front of you. Above and below. To your left and right. The Big Bang happened here, where you're sitting right now. The space you occupy was part of that initial hot, dense state. It's been expanding and cooling for 13.8 billion years. But it was always here. The atoms in your body were forged in stars that formed from the cooling remnants of the Big Bang. Those stars exploded as supernovae, scattering heavy elements into space. Those elements condensed into new stars and planets. Eventually, into Earth, into you. You are, quite literally, made of the Big Bang. Every atom in your body participated in that cosmic expansion. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it traces back to that initial moment when the universe was unimaginably hot and dense everywhere at once. And so we arrive at a truth that's both humbling and strangely liberating. We are not at the center of the universe. But we're not in the outskirts either. We're not in a special place or a neglected corner, not in the prime real estate of the cosmos nor relegated to some cosmic slum. We simply exist at one of countless points in an expanding cosmos, each one equally valid, each one with its own perspective on the whole. The Copernican principle, the idea that we don't occupy a special position in the universe, has evolved over the centuries. First, Copernicus showed we're not at the center of the solar system. The Earth orbits the Sun, not the other way around. Then, we learned we're not at the center of the galaxy. Our Sun is about 26,000 light-years from the galactic center, in a minor spiral arm called the Orion Spur. Nothing special about our location. Then, we discovered we're not in a special galaxy. The Milky Way is a large spiral galaxy, but there are billions of similar galaxies. We're not unique. Now, we know something even more profound: there is no center to be away from. The question itself dissolves when you understand what the universe actually is. The concept of center doesn't apply to the universe as a whole. Every point in space has an equal claim to being the center, which means the universe is, in a sense, the most democratic structure imaginable. No privileged locations. No cosmic hierarchy of important versus unimportant regions. Just space, expanding uniformly, with every observer seeing the same fundamental patterns. It's a strange kind of equality. Profound and dizzying. We're nowhere special, and yet everywhere we look, we're at the middle of everything we can observe. This perspective has philosophical implications that extend beyond cosmology. If no point in space is privileged, if there's no cosmic center, what does that mean for how we see ourselves? For how we treat each other? All of it centered on you. All of it radiating from your equally valid position in the cosmos. The universe has no downtown, no main street, no coordinates you could plug into a cosmic GPS to find the origin point, no "you are here" marker that's more valid than any other. Because the origin point is everywhere, and everywhere, it turns out, is exactly where you are.